No. Okay, good. So if you don't have any problem, I will continue. So today we're going to finish up 14.1. We're going to do a few more examples of partial derivatives. And then we move on to 14.2, where we will do the second partial derivative. After that, we are going to look back into 14.1 and of course 14.2 to review some of the applications of certain of this kind of derivative. So let's go to 14.1. I'm going to finish up this section. And what we will do today for 14.1 to finish it up, we're going to look at the multiplicative terms of the two variables x and y. What we have been doing earlier, okay, last class, the x and y, the two variables, they are additive terms. That means x and y, they are added, in the equation. Today we're going to look at what about if they are multiplicative terms. That means x, y are multiplied. And we can consider that as a single term. Okay, so that is what we want to continue on. So we already did that, but when we say x and y are multiplicative, it's like you have a term, okay, and then x, y, they are multiplied to each other, just like 3 times 4 or 4 times x. So now you have something, x multiplied by y. So I give you an example. Let's say I have f of x, y equal to z, say equal to 4x to the power of 2, y to the power of negative 3.5 plus 10x to the power of 3 over 10 plus, oh, now I think we do one minus, minus 21 x to the power, oh no, I'm sorry. We make it y. Y to the power of 6. Okay. So here, if you look at one term, okay, the first term, they are in multiplicative. In other words, the x and y, they are multiplied to each other. Because you have, the first term, you have x squared multiplied by y to the power of negative 3.5. So that is what I say, they are multiplied to each other. X multiplied by some terms in y. So this thing here, since they are multiplied, is considered just one term. So you think of the x multiplied by y, okay, x terms multiplied by y. Think of it x as coefficient of y. If you do the derivative with respect to y, or y is a coefficient of x. When we are doing the derivative with respect to x. So y as a coefficient of x when you do the derivative with respect to x. x coefficient of y when we do derivative with respect to y. So think of it as a constant, okay? And that is the coefficient of the variable that we are going to take the derivative with respect. So that is the type of term, that we are going to encounter. Of course, we already did. You have a single x and a single y, there is no problem with that. We already did. That means the additive terms or subtractive term, we already did that. So now let's do the multiplicative part. So first of all, let's do the derivative with respect to x, fx. So now what we start with something that we already know, okay? So the second term, the third term, we already know how to do the derivative. For the first term, they multiply to each other. That is what we're going to do. Okay, now, look at the second term, the third term. What is the derivative, the partial derivative, fx? Apa dia? Here, second term. 10x to the power of 3 over 10. What is the derivative? Hello, can you hear me or you cannot hear me? Because I hear the voice, I heard some sound. But can you hear me?
Yeah.
Yes.
Okay,
Yes.
good. All right. Take the derivative of the second term, 10x to the power of 3 over 10. What do you get?
3x
Is power of negative
power
7
of negative 7 over 10.
over 10.
3 over 10 minus 1. So that becomes negative
Negative 7
7 over 10. Okay. Now the third term, y, is a constant. So that will be 0. Okay. So we are going to do the first term. Now, what is the derivative of that term for x squared y to the power of negative 3 over 5? So here, the y is a coefficient of x because we're going to take the derivative with respect to x. Okay, so think of it as this way. Y now is the coefficient. So you put that coefficient y together with the constant already there, which is 4. So you got y to the power of negative 3 over 5. So that is the constant. Okay, y now is a constant. So that constant, think of it, or y, think of it, which is the coefficient of x. That's another constant. So don't worry about the derivative of that thing. Just keep it as it is. Okay? So the variable that you have is what? X to the power of 2. So you just take derivative of the x squared. Don't worry about the y to the power of negative 3 over 5 because that is coefficient of x, just like the number 4. Okay? So what do you get? You just take derivative of x squared. So you have, okay, I just put the terms for y to the power of negative 3 over 5. Put a bracket so that we know it's a constant, 2x. Okay, derivative of x squared, 2x. And of course, you multiply out the 4 and 2 becomes 8. Okay, any question about that? Now, when you have the multiplicative terms in terms of x and y, okay, the other variable, you just think of it as a coefficient and it's a constant of the variable that we are going to take derivative of. Okay, all right. Now let's do fy. Now, when you do fy, the x now is the coefficient of y. Okay, the x now is the coefficient of y. So put that together. So you have 4x squared. So that's the coefficient of y. Think of it as a constant. Okay, 4, of course, is a constant number, but x squared now is a constant. And the variable y is raised to the power of negative 3.5. So you just take the derivative of y to the power of negative 3.5. The constant here will just follow. Okay? So what is the derivative? You have 4x squared multiplied by negative 3.5. Since it's a negative for the bracket. Because sometimes that can become, subtraction. Now we multiply. So negative 3.5 y reduce the power by 1, that becomes negative 4.5. So that is for the first term. All right. Now you have another term in y, so that is very easy. That is minus 21 multiplied by 6 y to the power of 5. And of course, some of the constant you can multiply out. Okay? Okay. Clear? Any question about that? All right. So go to 14.1. I'm going to give you example, where you can do another exercise. Go to 14.5. Oh, no, I'm sorry, 14.1. We will do something like that. Okay. I would like you to do question number, I do not know whether I assign to you this question or not. 14.1. Do question number 10. Okay, 14.1, number 10. Now, number 10, you have z is equal to 4x squared minus 3xy cubed. Okay, do that one. So be careful. Okay, the second term is y multiplied by x. So consider that variable or the other variable, as a coefficient of the variable that we're going to take the derivative with respect to. Okay. All right. Now do it in 1 minute. Hey, did I give you a question on 14.1? Belum lagi tak? Because we just started the derivative. No, I don't think I have. Okay, what is the partial derivative? First, now the function is z, all right? So I use fx. I think we just use fx, easier to write. Or you can use zx. So what I do, even though the function saying z as a function of x and y, but when I take the derivative, I use f, because f stands for function. Okay, now what is the derivative of f, or I mean, the derivative of the function with respect to x? What is it? Now tell me, what is the first term? X cubed. Take derivative with respect to x, what do we get? We get 3x squared. Okay. Now, the term number 3, y squared, is a constant, so that's 0. So don't worry about that one. Now you have the second term. Okay, 4xy. What is the derivative with respect to x? Anybody? Huh?
4y.
4y. Okay, is it 4y? Everybody got 4y? So you got 4xy. I'm going to write it here. Okay. Now we're going to take the derivative with respect to x. So that y is a constant. So you just write it together for y. Okay. And then you have the x. Just differentiate x. So what do I get? I get x to the power of 0. So 1. So this becomes 4y. Okay. All right. Good. Now what about fy? You take the derivative with respect to y. Okay. So you got the term number 2 for xy. So what is the derivative?
4.
4?
4x.
4x. Okay, again here. you get 4xy. You want to take derivative with respect to y. So the x now becomes a constant. So just a coefficient of the y. The thing that you're going to differentiate is y. Okay? So y to the power of 1, what do I get? I get y to the power of 0. So that would be 4x. Okay? Now it's not 4. Okay? It is not 4. That is wrong. It's not 4. It should include the variable that you keep as constant. All right? Which is your x. If you say 4, then what happened to the x? You cannot throw the x away. Okay? So it is not 4. It is multiplied with the variable that we keep constant. Here, x. Okay? So make sure we understand that. Huh? So it's 4x plus the derivative of the y squared. So you got 2y. Okay. Any question? All right. I give you another example. Okay. Another example, we do question. I'll give you another question. I will. Okay. Example number 2. You know, I want to give you not just x, y, no, give another term multiplied with. So I got f equal to negative 5x to the power of 2/6 minus 34 x to the power of negative half. No, not negative. Make it half. Make it 1/3. Okay, negative 1/3. No, negative, positive. Y to the power of 7.6. Don't worry about the decimal point or the fraction. Okay, as long as we keep the rule. Plus berapa? Plus 89. Okay. All right. Now I want you to find fx and then fy. So make sure this is correct. All right. So I want you to try to do this. So if you know in the process, just put the variable that is we consider constant together, okay, with the actual constant. But after you are familiar, then you don't have to do that. Okay, just keep it as the original term. Okay, we do one at a time. Okay, do fx first. Anybody who's done it, let me know. Okay. What is the derivative? First term. Negative 5.
5/3.
Multiplied by 2/6.
Oh.
Okay, don't simplify it, you know. Just give me the original terms.
Right.
Now what about the x? You reduce the power by 1, so that becomes what? Negative
2/3.
2/3.
Negative 4/6. Okay, put 4/6 first, so that we can see how you take that value. Okay, after that, of course, you can simplify it. Okay, now the second term. All right, give me the derivative of the second term.
Negative 34 times
Negative 34 multiplied by
1/3
1 over 3.
1 over
Alright.
3.
And then
Oh, 1 over 3.
x
By
reduce the power of the x by 1, so that becomes what?
negative
Negative
2
2
over
over
3.
3.
Okay. All right. Anything else? What about the y?
y
Y 7 power of 7.
So the y will be just a coefficient of the x. Okay, it's a constant. So don't throw that away. So that will be y to the power of 7.6. Okay, so after we already know the method, so you don't have to rearrange. Okay, you don't have to arrange the x and y to indicate the coefficient. All right, but if we are still learning, okay, it is good that you put them together. So I will do that. So for that one, okay, I think I will take this out. So for that term here, you put the y and the 34 together as a constant. So that one, you think of it as negative 34, y 7.6. So together they are the constant. And then you have the x, negative 2 over 3. So you take derivative, which is exactly what you got there. Okay? All right. So you just take derivative. I'm sorry. It's not negative 2 over 3. It's 1 over 3. Yang tu dah derivative lah tu. 1 over 3. 1 over 3. Okay? So what you got will be here. Of course, you put the y lah, together with the 34. Okay. All right. Now do the fy. Take derivative with respect to y. What do I get? Okay, what do we get? For the first term, of course, that is 0. Okay, there is no y, so that will be 0. Now for the second term, what is the derivative?
Negative 34.
Negative 4 times 7.6
Okay,
34
multiply by 7.6.
x.
What?
X.
You keep the y, the x, okay, it's a constant.
x.
And then you multiply by the y, which is the one that you differentiate. All right. So that will be y negative 7.6,
Y
7.6
6.6.
minus 1, 6.6. Okay. So I think I will reorder this thing because you put that thing, the constant before the x. So I will reorder that. So you got negative 34. Okay. Multiply with the x. And then you take the derivative with respect to the y. Okay, so you got negative 34 x to the power of 1 over 3. Okay. And then you multiply that by 7.6. Okay. Y. Reduce the power by 1, 6.6. So that we know it is the coefficient of the y. Okay. All right. Okay. So good. I'll give you another example. Now let's say we have x, f of xy equal to 4x squared plus y to the power of negative 5. multiplied by 5. No, 5. Banyaknya ni. Multiplied by 31 x to the power of 10 y to the power of negative 4 point berapa? Negative 6.9. So here, we're going to apply the product rule. All right? You're going to apply the product rule. That means just like U times V. So you apply the product rule. You take derivative of U multiplied by V plus derivative of B multiplied by U. Okay? And then you take derivative, of course, by applying the partial derivative. Okay? All right. So if we do that, we know the derivative, okay, U prime V plus B prime U. So that rule apply. So if you want to find fx, that means you have to take the U prime V plus V prime U. Now that prime, all this prime, all the derivative, of course, must be with respect to x. Okay, because you have the x there. Okay, all right. So you let U be equal to the first term. So let's say I got U equal to 4x squared plus y. And then you take V as the second term, 31 x to the power of 10, y to the power of negative 6.9. So here is respect to x. Okay, so that prime, you can use du dx, you know, but du dx, you have to spend a few more minutes, you know, writing that thing. So I just use u prime. So u prime is equal to what? Now here you take derivative with respect to x. So there will be what? X plus 0. And what is v prime? That is derivative with respect to x. So that will be 31 multiplied by 10 x to the power of 9. Now y don't change. It's a constant. So y to the power of negative 6.9. So put into the formula, you get f of x equal to what? Equal to u prime v. Now what is u prime v? Now you remember how to do the u prime v? You have to take away the power, take down the power, multiplied by everything in the bracket, reduce the power by 1, okay, multiplied by u prime. Okay, so that is how you get the u prime. U prime, which is what? 4x, and I'm sorry, not 4x, 8x. Okay, multiplied by 8x times v. 31 x to the power of 10, y to the power of negative 6.9. And then you have to add v prime times u. So what is v prime? V prime is 31 x to the power of 9, all right? Y to the power of negative 6.9, that is v prime. Okay, put a bracket. And then multiplied by u. U is 4x squared plus y, everything to the power of negative 5.
So it's 310 V prime.
310.
10.
So 31 multiplied by 10. Okay, I missed that 10. Actually, I didn't multiply out. So you multiply by 10, I put a 0 there. Betul. Okay, multiplied by u, which is 4x squared to the power of negative 5.
Yang bawah.
Apa dia?
Yang atas tu V. Yang bawah V prime.
Yang mana satu V prime? Betul. Thank you. Saya pun pergi multiply semua. Yang ni tak ada benda tak. Yang ni betul lah, 31 je. Okay. You're right. So that is 31 x to the power of 10 y to the power of negative 6.9. Okay. So that 310 is for the V prime. All right. So, it's just a matter of doing more work, okay? But the rules are the same, okay? The rules are the same. So now let's do the second one, Fy. Now when you do the Fy, again, the formula is the same. U prime V multiplied by V prime U. But now the prime is with respect to Y, okay? So I just use U prime, okay? Or you can use du dv, du dy plus v prime u. But here, you know, it's with respect to y, okay? Not with respect to x. So we are done with that one. We do the u prime, okay? Now u prime here is with respect to y. So I will not write u because I already got that u here. So you take that derivative with respect to y, what do I get? Very simple, that's 1. Okay? And then the v is already there. I take v prime, what do I get? Now the x is a constant, which is x to the power of 10, okay? X to the power of 10, that is a constant, so don't worry about that thing. We worry only about the y. So y to the power of negative 6.9. So you multiply that by negative 6.9 times y, reduce the power by 1, so that is negative 7.9. Is that right? Is that? Okay, because now you take derivative with respect to y. Okay, so after you do that, masukkan balik dalam tu. So you don't have to simplify, all right? You can simplify if, it's just multiplication of constants. Like here, 5 times 4, so that becomes negative 20. 8 times 31, and then 310 multiplied by this. Other than that, oh no, you cannot do that. Okay, you cannot just multiply 310 and 4. Okay, so the second term here, just keep it as like that. If you have some constants that you can multiply small enough, then you can do it. Otherwise, don't worry about it. Okay, just keep it as, I think just keep it as it is. Because you have to multiply multiply. No, you cannot multiply. I'm sorry. You cannot multiply. Because you have a plus here. You can only multiply. Actually, you can only multiply 5 dengan 8. Okay, 5, 8, and 31. But you cannot multiply by the 4 inside that bracket. So to avoid making mistake, tak payah multiply out. Okay? If we only want to find the derivative. Of course, if you want to find another thing, maximum or minimum, then you have to simplify it up. Okay? So finish it up, this one. So you got it? So you put everything in the formula. Okay, u prime is 1 multiplied by v and then plus v prime, which is the one that I got there, multiplied by u. Don't have to simplify. Okay, all right, good. Now I would like you to do another one. Do question number 5. Now that question require you to apply the quotient rule. Okay. So can you do number 5 on 14.1? Apply the quotient rule. We already do the product rule. Okay. So now do the quotient rule. Okay, do it now. I'll give you 5 minutes. Or, or maybe shorter, depending on how long can be completed. Okay, got it? So you have U over V, okay? So apply the formula. Okay, you got it? So you got here U over V, question number 5. So you let, question number 5. So you let U be the term in the bracket, all right? So first thing that you do, of course, fx, which is equal to what? The formula says U prime V minus V prime U, everything divided by V to the power of 2. So now the prime is with respect to x. So if you know that U is equal to what? 4x cubed y minus x. Okay, so what is U prime? Take derivative with respect to x, so you got 12x squared y minus 1. Is that right? You know the y is a constant, then you take derivative of x cubed, you got 3x squared. Okay. Now, v is 2x minus y. Then what is v prime? V prime is just a 2.
Aku dah siap.
Okay? Alright, now masuk balik dalam
Kau
tu.
boleh pilih kau nak direct transfer ke bank ataupun through carousel. Aku tak reti pakai carousel tu, aku baru lagi, aku tak reti. Aku suruh dia transfer terus. Lepas tu, sini aku.
Syuhada. Syuhada.
Boleh tanya email aku.
Syuhada. Syuhada. Cakap apa tu? What is the problem? Huh? Syuhada. I'm talking to you. What are you doing? Okay, if you want to discuss this question, okay? Don't talk about something else. Siapa ni tadi? Siapa emang? Sauda. Alright. Okay, I want you to do this, not talking about something else. Alright. If you want to discuss about that question. So you put in that thing, you got fx. Okay. So what do you have? You have fx equal to u prime. Okay, u prime is 12x squared y minus 1 multiplied by v, which is 2x minus y. And then take away v prime, which is 2, multiplied by u, 4x cubed y minus x. Everything divided by v squared. So you got 2x minus y squared. Okay. Now, similarly, if I want to find fy, okay, fy, you still use u prime v minus v prime u divided by v squared. But now, make sure you take derivative with respect to y. Okay, janganlah v prime hitamnya x kok. Okay, do derivative with respect to y. If you are not sure about that, then you can use the df dy. Okay. But the reason I use y prime or u prime, I'm sorry, u prime, v prime, it's easier to write. But make sure we know the variable to which we are taking the partial derivative with respect to. Okay. Any question? So I have reviewed product rule, right? And then this is the quotient rule. Like I said earlier, all these rules will apply. So that is 14.1. Oh no, I'm sorry, 14.2. Okay, and of course 14.1. So now we move on to the next part, which is the second partial derivative. So here, the second partial derivative, I have the function. It's just the derivative of the first derivative. Okay, just like the second derivative. I have a function z as a function of x and y. Okay, you have the first partial. You call it the first partial. The first partials are what? Fx, Fy. Okay, derivative with respect to x, derivative with respect to y. Now, Fx and Fy, these are functions. Okay, so you have Fx. We can also call it Fx, Fx is a function. You can call it what? Call it, you call it another label. Z as a function of, because I already used Z. Okay, but think of it as another function, okay? Actually, you can call it Z, okay? It's Z, but now it's the Fx. It's not Fx anymore, but they are function of X and Y, all right? And similarly, Fy, you can call it Z because we're talking about X, Z, X, Y. Now it's Fy, and it's a function of X and Y. So we can take the derivative of this function since they are functions. So we can take the partial derivatives of Fx, Fy. That we call the second partial of f. Okay, second partial of f. Yeah, second partial of f. I hope using z here, you will not be confused. Probably we can use another letter. Okay, but don't worry about the z. I just focus on the fx and fy. Okay, so you take the derivative of fx, derivative of fy. That would be what? that will be the second partial derivative of the function, the original function. So you denote that by the following. You got number one, you got fxx. Okay. Number two, you got fyy. All right. So fx is a function of x. You take derivative with respect to x. You got fxx. Okay. So fxx is the derivative of the function fx with respect to x. And then you have fx, I'm sorry, fy. Okay. You take the derivative with respect to y. So you got fy, y. Okay. Now fx is also a function of y. So we can take derivative of fx with respect to y. So you write that fxy. Similarly, fy is also a function of x. So we can take the derivative of fy with respect to x. So partial derivative, or the second partial derivative, you have fxx, fxy, which is the derivative of fx with respect to x and with respect to y. And then for the second one, the fy, you have fyy, and then you have fyx. All right. So these are the second partials. We call it second partial. So the first partial, you have two. Second partial, there are four. All right. Because you see here, fx is a function of x and y. Fy is also a function of x and y. So you take derivative of the derivative with respect to the two variables. All right. Now you call this thing here is the direct second. Okay. This one is, you can call it cross, because you are taking the derivative with respect to the other variable. So you can cross partial. This one is direct. But the most important, that will be our second partial derivative. Okay. So it's the derivative of the derivative, just like what we were doing earlier. But now it's with regard to a function with two independent variables. Okay. So that is second partial derivative. Okay. Is that clear? All right. So, example, we go back to the questions that we have been doing. It's easier to do that. We start with something easier. Ada lagi tak question yang lagi senang nak buat? Tak ada. Ini je lah. Okay, so let's go to the example that we have earlier. This one. I think we start with a simpler question. Okay, we start with a simpler question. That one tu susah sikit. So after we do the simpler one, then we come back to the second one. You know. So I give you a simpler question. Okay, do question number 1. Question number 1 on 14.1. Okay, you got simple example, x squared plus y squared. Okay, can you do the the second partial derivative. You have f of x, y, equal to x squared plus y squared. Ini very simple. All right. So what is fx? We can do this quickly. Fx equal to what?
2x.
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 Good.
2x.
2x. Fy, 2y. Okay. So if you look at this thing here, fx is a function of x and y. Of course, there is no y there. And here, fy is a function of x and y. Of course, there is no x because it's a, also constant. Anyhow, we do the second partial derivative. So fxx. And then you need to find fxy. So fxx means derivative of fx with respect to x. So what do we get? We get 2. Okay. So the derivative of the first partial, fxx, means you take derivative of fx with respect to x. All right, so just 2. Now fxy, take derivative of fx with respect to y. So what is it equal to? There is no y there, so that is 0. All right. Similarly for this one, I got fyy. Take derivative with respect to y, that will be equal to what? 2. Now what about fyx? Take derivative of fy with respect to x. I got nothing, 0. Okay, so this thing here is very simple. So that is just to give you an idea of how to do the derivative. So we go on, consider the examples that we have earlier for some function. That is, mana function tadi? Ini function yang mana pula ni? Oh, that was question number, that example that we have. Okay, this is a good example. So here, you have fx already, okay? And then I have fy there. So now, what you do the derivative again, okay? So for fx, we need to find the derivative of fx with respect to x, that is fxx. And then take the derivative of fx with respect to y, so fxy. So in that sense, maybe you need to multiply out the constant wherever possible, so that you can do the second partial derivative. So I want you to try that. Okay, there shouldn't be any problem because we already have done the first derivative. So the second partial is just an extension of that thing. Okay, so do it now. Finish it up. Do the fxx and fyx. Okay, you got fxx. So for this question, for that example, I'm sorry, you have fx equal to, so now you multiply out the constants, okay, so that you have a more organized equation. So you got 3x to the power of -7/10 plus 8x y to the power of -3.5. Okay, is that right? So now, what do you get? I take derivative of fx with respect to x. So y is a constant, all right? So what is it equal to? So now you got what? 3 multiplied by -7/10
7/10.
x. Okay, -7/10 minus 1. So that becomes negative
-17/10.
17 kan? -17/10 plus. Okay, here there is x. So that becomes simply 8. Y -3.5. Okay? Any question about that thing? Everybody got this? If you make a mistake, check again. You know where your mistake is. Okay? So you can just check by yourself. So you can easily check where the mistake that you did. Okay? Now, take the derivative of fx with respect to y. So fxy. The x now is a constant. So x is a constant. So that one is 0. So you only have the second term to deal with. So you have 8 multiplied by -3.5 x. Okay, x is a constant. And then, or you can put, I'm sorry, I think we should put x at there first. So the y, the x is a constant, the variable is y. So I put the x there, okay? So you got 8x multiplied by -3.5, and then reduce the power of the y by 1, so that becomes -3.5 minus 1, that becomes -4.5. Okay, everybody got it? Now, if you got it wrong, okay, check where you make your mistake. Oh, ni Akmal, dia say v prime equal to 1. Huh? Itu, you should, tadi apa saya tak cakap? Okay, now go back to this one. If the y is a constant, if I take u v prime, okay, so go back to this comment. I think you're right. If y is a constant, okay, then what is v prime? Go back to this one. Yang Akmal tadi apa saya tak cakap. Ni dulu kat chat. Mana saya nampak? Okay. If you do the derivative respect to x, that means y is a constant. So what is v prime? Yang ini cakap ni. Patutnya berapa ni? Akmal. You raise up this benda question mark ni. V prime should be what? Anybody lah. No, if that y is a constant, what is v prime? That means take the derivative respect to x. But what is it? Shouldn't be 1. It should be what? Hello? Should be apa?
2 minus 1.
No, y now is a constant, okay? Y constant. That means v prime is derivative with respect to x. So what is the v prime? So for that one, right?
2.
If y constant, okay. If y constant, then what is v prime? Should be what? That's correct. Shouldn't be 1. It should be what?
2. 1.
Yeah, should be 2.
2.
Okay, should be 2. So you go back to my notes. I'm not going to bet. Okay, that's 1. Now, if x is a constant, okay, I did not know where the mistake was. If x is a constant, then v prime is equal to what? Shouldn't be 1 also. Should be what? Should be what? Should be negative 1. Okay, because v prime is dv dy, derivative of v with respect to y. Okay, so that will be the thing. So Akmal, lain kali kalau saya buat silap, cakap je lah. Okay, tak susah. You know, nobody see you. You know, you can talk by yourself. Nobody see you. I don't see you. I only know your name. If I make a mistake, cakap je. Okay? Ni put dekat chat. Susah lah, saya tak tengok chat. Saya tengok saya tukang tulis. Alright? So thank you. Anyway. Okay, so you go back to this thing here. If I make a mistake, that would be, I mean, let me know. Okay, so for that thing, that should be the thing. Okay, now come back to here. Betul ni? Is that fx, x, fy, y. Okay, check. Any mistake that I do? Jangan letak kat chat, okay? Any mistake, you let me know now. Betul kan? Okay. Now, the second part, I got fy. Fy, if I can rewrite it, I got negative 14 x squared y to the power of negative 4.5 minus 126 y to the power of 5. Okay, betul ke tak betul ni? Check. Nanti sekarang saya tersilap kau. Cakap lambat. Cakap sekarang. Ada silap tadi. Betul FY tu? Betul?
Betul.
Betul? Okay, good. Sebab I multiply tadi. Sometimes, you know, you make mistake when you multiply out. Okay. So, what you do, you take derivative of y with respect to y. Fyy. So, x is a constant. So, don't worry about the x. So, you got negative 14 x squared. Okay, that's a constant multiplied by negative 4.5. You reduce the power by 1, so that becomes negative 5.5. So you can multiply lah, negative 14 and negative 4.5, that becomes positive. Okay, and then here you got 126 multiplied by 5, y to the power of 4. Okay. If you make a mistake, okay, check again. Where was your mistake? To make sure we take care of the mistake. Okay, now take derivative of fy with respect to x. Now x is the variable, y is a constant. So that one. So you have what? I have negative 14, all right? Multiplied by 2x. Okay, derivative of the x squared. And then you have y to the power of negative 4.5. Plus, okay, you got y here, y is a constant, so 0. So that would be our derivative. Okay. All right. Now, our rule is, okay, I mean, if you want to check whether this is correct or not, fxy must equal fyx. If they are not equal, that means something is wrong somewhere. Okay? So what you do now, multiply out lah. Tengok betul ke tak betul. So 14 times 2, so that is negative 28. X to the power times y to the power of negative 4.5. Okay, hot ni. Boleh berapa ni? Okay, negative 3.5 times 8. Berapa ya?
Negative 28.
28.
Negative 28. Okay, negative 28 x y to the power of negative 4.5. So, as you can see, they are the same. So in other words, we are correct. Okay, you got fx is correct, and then of course that comes from fx. So fyx is equal to that thing, which is equal to fyx. I'm sorry, fxy. So that indicate our fy was right. Okay, so make sure this is not it's not assumption. Okay, it must be true. So you have to do it both. Okay, you have to do it both, and then make sure we have them the same. Okay, you have them equal. If they are equal, then our second partial are all correct. All right. So fxy must equal to fyx. Okay. Any question? All right. So that is good. Okay, I would like you to look at example number 4. Example number 4, 14.2. Okay, so go to the example 4. Example 4, 14.2, where you have the f of xy equal to x squared tu. X squared plus 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 ada square satu lagi. Betul? Not plus, minus. Should be a minus sign. Okay. And then we already have, of course, you do the fx, fy, and then you do the second partial derivative. So first, okay, I want you to find fx, and then you find fy. After that, you do the second partial, fxx, fxy. Similarly for this one, you got fyy, fyx. Okay, do it now. Actually, the first partial is already being done. So, but just to make sure, we know how to do it. So why not spend a few minutes doing the first partial as well. You got it? Okay, now let's do the fxx. So I already have the fx, right, which is as per given in the question. So now we want to find fxx. So derivative of, if you look at the example, that is the equation in part A. Okay. So what is the derivative of fx with respect to x? It means fxx. So what do you get? Give me the terms. Right. Hello?
For x.
Well, x squared. Okay, that's for the first term. Now, the second term, you also have x. So that becomes what now? You have only x. So that becomes 4.
-4.
-4.
So
Multiplied by
y
y.
y square.
Y
Y
squared.
square.
Okay, because y is a constant and that y is multiplied to the x. And now you do the derivative fx with respect to y, fxy. Now, first term, x cubed is constant. So that is a 0. And you have only y squared. So you got -4x multiplied by 2y. So that will be equal to -8xy.
xy.
Okay? Okay. Now, we do the second one, fy. Fy is as per given in part B. So we want to find fyy, derivative of y with respect to y. I mean, derivative of fy with respect to y. So you have the terms given, eh? So first term, what is derivative with respect to y? So you just got negative
-4x squared.
4x squared. Okay, because y is to the power of 1. So that just becomes 1. Plus, you got another term
Plus
in
12.
y, so that becomes 12y.
Y squared.
Okay, good. Okay, so now you take derivative of fy with respect to x. 4x squared. So fy with respect to x, fy with respect to x. So the first term here, there is an x. So you got -4, okay? And then you got 2x. So that will be derivative of x squared, becomes 2x multiplied by y. Okay, y is a constant. Or you can bring the y together with the 4. And then plus 4y cubed. Okay, that's a constant, so 0. That would be equal to -8xy. So as you can see, they are equal. So we are correct. Right? Our derivative is right. So that is the second partial derivative. Okay. So I give you some questions, for your practice. Go back to 14.1. Okay, 14.1. Question number 1 we already did. So you do question number 2, okay, and then do number 5, and then do number 8. Okay, don't find the domain. Okay, don't worry about the domain. Here I want you to find fx, fy. Okay, and then continue to question number 10. Number 10 kita buat tadi eh? Okay, number 10 we already did. So you do question number 12. Also, fx, fy. Okay, don't worry about the question saying find the value. And then give you one more question. I think that will be nice. So that question 14.1, fx, fy. Okay? And then what you can do, continue. Okay? Continue with the second partial. Continue with the second partial, just for your practice. So that is 14.1. Now 14.2. So question berapa tadi? 2, 5, 8, 12. Okay, good. So you have a quotient rule there. Okay. And then we'll go to 14.2. Okay, 14.2. I'll give you a few more questions. Okay, 14.2. 14.2. Okay. Do number 5. Do number 5. Kita lah. Senang kita buat sekali. 5 to 9. Okay? 5 to 9. And then one more. 5 to 9. And then question number 11. Again here. You do the question as what we were doing for 14.1. Fx, Fy, and then all the second partials. In other words, Fx, Fy, Fxx, Fxy, okay, Fyy, Fxy. So in total, there are 6. So just for your practice, do these things, 14.1, 14.2, okay? So make sure by Wednesday, you are already a master of doing the second derivative. Any question you can do, all right? So make sure we are able to differentiate. If the xy are multiplicative, which is, you know, the variable is the coefficient of the other variable. If it is additive, then very simple. So make sure we know how to do that. So for next class on Wednesday, we will look at application, okay? We will continue with the application of the what do you call it? Of the partial derivative. So we're going to go back to 14.1 and then 14.2 to review the applications. All right. Okay. Any question? Anything? Okay, good.
No, sir.
All right. So I will see you again Wednesday. Okay. Have a nice holiday. Dah siap lah. So have a nice doing the homework. And I understand there are many people who are doing the tilawah. Okay. Now, if you were doing tilawah test during our class time, make sure you get the note from your friend, right? Because sometimes I put the recording 1 day late or 2 days late. Okay. So get the notes from your friend. Easy now, you know, online. You just send the notes to your friend, and then make sure we know what is going on today. So with that, I end the class for today. Inshallah. Assalamualaikum warahmatullahi taala wabarakatuh.
Assalamualaikum.
Waalaikumsalam.